Polarimetry is used in chemistry in a variety of ways. The primary use is to determine the angle of rotation of an optically active substance using polarized light. The polarized light will either shift clockwise or counterclockwise, and the amount it shifts will determine the angle of rotation. Polarimetry is important in chemistry because it allows one to determine the difference between enantiomers using optical activity as a measuring point. Enantiomers are two stereoisomers that are mirror images of one another but are non-superimposable. There are other techniques in chemistry used for the identification of substances such as melting point. However, this test would prove non-conclusive for the identification of enantiomers in that they will provide identical melting point. The specific rotation value is dependent on a variety of factors, mainly the concentration of the substance used and the length of the tube placed in the polarimeter machine. This can be seen in the following equation. The polarimeter machine will be turned on by your TA prior to the beginning of the lab. Prepare your solution with your unknown substance and note its concentration. To prepare the solution using your unknown substance, weigh out the desired mass of substance and using a funnel, transfer it to a volumetric flask. Rinse the weighing tray and funnel using deionized water. Using deionized water, fill the volumetric flask to its midpoint. Fill the volumetric flask to the line with a glass pipette. Stopper the flask. Dissolve the solid by shaking the volumetric flask up and down. Next, ensure that the polarimeter sample holder is clean. Note that there are 3 sections to the polarimeter sample holder: the silver cap, the black washer, and a clear lens. Be careful not to break the lens. Rinse the sample holder with deionized water and then empty into a waste beaker. Next, use deionized water to calibrate the machine. To do this, fill the sample holder to the top with deionized water and ensure no bubbles are present. If there are bubbles present, tilt the sample holder to ensure the bubbles are in the curved part of the holder and not in the top or bottom of the sample holder. Next, open the hatch of the polarimeter and place the sample holder into the tube opening and then close the hatch again. To calibrate the machine, ensure that there is a uniformly colored circle visible through the eyepiece. Note that the inner and outer zeros on the vernier scale are aligned, which shows that the machine has been calibrated. Next, discard the deionized water in the waste beaker and fill the sample holder with your prepared solution. Ensure minimal bubbles are present, or if they are present in the curved portion of the sample holder as shown previously. Place the sample holder back in the machine and begin to take the reading. You should observe a half dark circle on the left and a half dark circle on the right when you rotate the dial in opposite directions. Adjust the dial so that one full circle is seen. Now, you can read the observed degree of rotation using the numbers on the outer dials. The outer scale is the whole number for the observed rotation reading, and the inner scale is the decimal point for the observed rotation reading. To make the reading, note where the 0 on the inner scale meets up with the numbers on the outer scale. In this example, the whole number is 1. To note the decimal, see where a line in the inner scale matches up with the line on the outer scale. In this example, the decimal number is 1. Therefore, for this sample, the reading is 1.1. If you take your reading on the left side of the machine and the 0 on the inner scale is above the 0 on the outer scale, this means you have a sugar that has a negative degree of rotation. If you take your reading on the right side of the machine and the 0 on the inner scale is below the 0 on the outer scale, this also means that you have a sugar that has a negative degree of rotation. To complete this reading, take the number you obtain and subtract it from 180 degrees. When you find your observed optical rotation value, you are able to solve for the specific rotation using equation 1. Divide this observed optical rotation value by the concentration of your solution and the length of the tube. This final optical rotation reading can be used and compared to known literature values to determine what the compound at hand is. As you can see from this tutorial, polarimetry is a useful and efficient tool used in the field of chemistry for the determination of chiral molecules with optical activity, such as enantiomers. Polarimetry can also be used for the determination of enantiomeric excess of a mixture of enantiomers. At the end of your experiment, ensure that all utensils are properly sterilized and returned to their designated location. Discrepancies in your findings with literature value may be a result of experimental error, such as sample preparation or incorrect reading from the scale. Ensure that all results, as well as potential sources of error, are copied down in your lab notebook.